Okay, so in this video I'm going to have a look at integration or anti-differentiation, and I'm just going to have a look at the basics of integration. So let's just start off with differentiation first. So let's have a look at some examples of differentiation, then we'll move into anti-differentiation. So let's just take we'll do 6x squared first, okay, with respect to x. So what happens when you differentiate 6x squared? Well, we know from previous videos that you take the power here, you bring it down here in front of the x and you multiply, and then you subtract 1 from the power. So we actually get 12x here, okay? So 2 times 6 is 12, subtract 1 from 2, you get 1 as your power here. So let's have a look at another one then. If we take the differentiation, if we want to differentiate 6x squared plus 2, for example, with respect to x, what do we get? Well, again, we differentiate these terms individually. If we differentiate 6x squared, again, we get 12x. If we differentiate 2, we'll get 0. So there's a plus 0 here, which I won't put in. We get the same answer as up here. We'll do one more. Let's take let's say 6x squared plus, let's say the square root of 2 with respect to x. So in this particular case, we also get 12x. Differentiate 6x squared, you get 12x. Root 2 is just a constant, so that's 0 again. So we just get 0 here. Okay, so in all three cases, when we differentiate three different functions here, three different expressions, we got the same answer in all cases. Now, how does this tie into integration or anti-differentiation? Well, anti-differentiation is just what it says. You are doing the opposite of differentiation. So in other words, when you find the antiderivative of 12x, you get 6x squared. Now, there's a problem here that you can probably spot immediately, in that if you get the antiderivative of this 12x, you get a different expression here. You get 6x squared plus 2. If you find the antiderivative of this 12x here, you get 6x squared plus root 2. So how can you get the antiderivative of the same term and get three different answers? Okay, so let's have a look at that. Now, firstly, the symbol for integration or anti-differentiation is this elongated S here. It's just an S that has been stretched out, and this elongated S here is called the integral symbol or the integral sign, and it is called an indefinite integral, and we'll have a look at why that's the case later on in other videos. But this is the symbol we're going to use, and what we're going to do is find the antiderivative of 12x with respect to x here. So you put in your dx here again, as you do here. So we want to find the integral of 12x with respect to x, but we already know that that's going to be 6x squared. Now the problem is, we can also get 6x squared plus 2 or 6x squared plus root 2 if we do the opposite, if we go in that direction. We can get three different answers by just integrating or finding the antiderivative of 12x. So what we actually do is we put in a plus c here as well, and this is called the constant of integration. This is called the constant of integration. So that's c. So in other words, if we differentiate 6x squared plus any constant with respect to x, we will get 12x, because we get 12x here, and if you differentiate a constant, you'll get 0. So we just put in a c here to represent any of these constants. Okay, so that's it generally, how you do, or what integration rather is, or anti-differentiation is. Now let's look at the general rule. How do you actually integrate generally speaking. So again, let's start with differentiation, and I'm going to look at differentiating this particular term here. It's x to the power of n plus 1 over n plus 1. Let's look at differentiating that particular fraction with respect to x. How do we do that? Well, let's have a look. Well, again, what we know we need to do is take the power here, bring it down here, and multiply. So let's do that. So the power is n plus 1. We're going to multiply that by x to the power of n plus 1, but then we've got to subtract 1 from the power. And we have our n plus 1 here on the bottom as well. So that's it there. If when we differentiate this particular term here, this is what we get. Now let's just simplify that. Well, we've got an n plus 1 on the top here, and n plus 1 on the bottom. They'll divide into each other. We just get 1. So we just simply end up with x to the power of n plus 1 minus 1 will give us 0. So we end up with this particular term here. So when we differentiate x to the power of n plus 1 divided by n plus 1, we get x to the power of n. Now, why am I doing this? Well, we know that from what I've done earlier then, that if I integrate or find the antiderivative of x to the power of n with respect to x, if I find the antiderivative of this, my answer will be x to the power of n plus 1 over n plus 1 plus my constant of integration. Now, this is the general rule you're going to use time and time again when carrying out integrations or antiderivatives, when looking for antiderivatives of individual terms. So in other words, how does this work? So to find the general indefinite integral, if you like, the indefinite integral of x to the power of some number, what do? Well, you take the number, the power, you increase it by 1, and then you divide by that particular power as well. And then you add your constant of integration. So let's have a look at how that actually works in practice. So let's take a particular example. So let's say we look at the integral of, or find the antiderivative of, let's just say x squared for the moment, x squared, fairly simple one. Now, how are we going to do this? Well, our rule here tells us that we need to increase the power by 1, so let's do that. X to the power of 2 plus 1, which is 3. Then it says divide by that particular power. Then add your constant of integration. So when we find an antiderivative, in other words, of x squared is x cubed divided by 3 plus our constant of integration. Let's see, does that work? Let's work backwards to see, can we differentiate this and get x squared? So let's do that. So we want to differentiate this time x cubed over 3 plus c with respect to x. Well, our rules for differentiation are that we differentiate each of these terms here. Well, this c will just become 0, so this is going to disappear over here. We're just going to get a plus 0. So we need to concentrate on this one here. So let's differentiate this. Well, to differentiate, as we know, what we do is we take the power, bring it down here, and multiply. So let's do that. So we have x to the power of 3. Now 3 goes down here as well. And then we've got to subtract 1 from that. And we have our 3 on the bottom here as well. And when we differentiate c, we get 0. So we just get 0 there. Now, this 3 will divide into this 3 once. So we're just left with x to the power of 3 minus 1, which is 2. Did we end up with x squared? Yes, we did. So look, we ended up with x squared here, and we have our x squared here. So when we found the antiderivative of x squared, we got this expression here. When we differentiated this expression here, we ended up back here at x squared again. Okay, so let's have a look at one more, and that'll be it for this particular video. Okay, so let's have a look at the integral of, let's say, 3x to the power of 4 plus, let's say, root 2x with respect to x. Now, let's do that. So we want to integrate this term first and then this term here. Now, another rule I should say, just when you're integrating, let's say, a constant times x to the power of n with respect to x, you can take that constant and just put it outside the integral symbol. So in other words, it becomes k times the integral of x to the power of n dx. So that's just another rule you can use. So we have a constant here, 3, so we can take that and put it over here. So it becomes 3 times the integral of x to the power of 4 with respect to x plus root 2 times the integral of x with respect to x. That's what we want to do. So we integrate each term individually and add them because there's an addition here. So root 2 here is a constant, so we brought the root 2 outside the integral here. So let's do that. So we've got 3 times the integral of x to the power of 4. So what's an antiderivative of x to the power of 4? Well, how do we do that? Well, what we said was we increase the power by 1, so that will give us x to the power of 5, and then you divide by that 5. So that's that one done. What do we do here? Well, we've got our root 2 anyway. Increase the power, this is the power of 1 here. So we increase that by 1, so we get x to the power of 2, divide by 2. Now, there is a constant of integration here, and there is a constant of integration here. So I'm going to combine the two and just call them c. Okay, I mean, you could call this plus c1 if you like, plus c2, add the two of them and you get this c here. But we'll just say plus c. This is our general constant of integration here. Okay, so let's just simplify that if we can. No, we can't do anything here really. It's just 3 over 5 x to the power of 5 plus, there is a way of simplifying that. I think I'll just leave it as root 2 over 2 x squared plus c. So when we find an antiderivative of 3x to the power of 4 plus root 2 x with respect to x, we end up with this here. And that's it in terms of just basic integrals, integration, antidifferentiation. In subsequent videos we'll have a look at more complicated ones. I mean, you'll have to know how to integrate or find antiderivatives of trigonometric functions and so on. And you'll also be able to find what c is. Depending on the problem that we're tackling, we'll have to work out what the constant of integration will be.